All right, the next topic we want to cover in lighting is that of HDRI lighting, and of course this is quite the rage these days for very good reason. It gets us much closer to proper integration with photographic live backgrounds than any other method can. And that's the brilliance that Paul Debevec had with HDR, is that why are we trying to basically kill ourselves trying to match photography when in fact photography can govern CGI creation by utilizing what it does best, which is deal with a dynamic range of lighting, a contrast ratio that can never be had by conventional CG. So there's really two approaches to using HDR. One is where HDR is used in its entirety as a means to provide key and fill. And the other way to use it is really more as a fill device for fill and specular reflection. And that tends to be, I think, what I favor, just because I have more control over the key light in that case. So that's the type of examples that I'll show here. We'll look at how HDRI is implemented in Mental Ray, and I'll go ahead and show you an example of how it's implemented in RenderMan, or at least one way. And then lastly, there's all types of experimental possibilities with HDRI as far as using animated sequences of HDR or having the HDR animate itself, and we'll talk about that. Alright, well, HDR starts with acquisition of the HDR image, and this shows a sample standard type of acquisition using a 3-inch reflective bearing, and then opened up into HDR Shop, the standard editor for HDR images. So on HDR Shop's webpage, you can find plenty of tutorials about how to do the acquisition of these images. The main result from this, though, is that we can bracket up our exposure, and this is built in to the HDR file format. This was taken with 11 brackets, which tends to be every other stop, which tends to be a good kind of rule of thumb for acquisition. So once we've assembled the base HDR as a series of images from Create, Assemble HDR, we now have the mirrored ball cropped down. We need to convert this to a lat-long image, a latitude-longitude image, because we'll be working in Mental Ray with this. At this point in time, the Maya renderer has no real way of working with HDR, so we will naturally work with Mental Ray. So in this case, we go to Image Panorama, Panoramic Transform, and we take it from mirrored ball at a 1K res to a lat long. And this will always be at a 2:1 aspect ratio because this is going to be spherically projected in Mental Ray. This resets the gamma curve in the viewer. What I've found here, if it's looking proper in a 1.0 gamma curve in HDR Shop, it will render well in Mental Ray. So color space is one thing that seems to have not been standardized with HDRs much. You can find a lot of varying gammas in the different products and or HDRs you may find from different authors. And ideally you want to remove yourself from the shot, which I've not done on this yet. And there's a decent tutorial for that on the HDR Shop webpage to instruct you on that. But the next thing we need to do once we've made a lat long is to create a selection. I usually select over the light source, and let's go to Image Pixels White Balance Selection, and this will put a color correction on the image, which I will show you proves to be relatively crucial. At this point, this can be saved out. What we'll do here is we'll save out save as an HDR or a floating point TIFF. I think Mental Ray will accept either one of those. And now we can move into Maya and actually work with a digital set with this image. Okay, so now I have a Maya file that's been set up to reflect the same background as the HDR that we just looked at. And this was shot as a high-resolution panorama stitched together to form a spherical projection for the image. Now, Maya doesn't do such a great job on texturing spherical surfaces, so unfortunately we can't see this in very high res, but during render time, of course, we'll capture the full resolution. So what I've done is I've placed the tempo file in the back part of the image, and now we'll begin to light this with the HDR that we have. So the next step here is to create a groundscape for the temple to cast a shadow upon for contact shadow purposes. If I look at this in wireframe and tumble, we can see the sphere that the panoramic image is mapped to, but the temple is floating out in space. Now if I have access to DEM files of the landscape, I can create a mental ray displacement and a polygonal mesh from that. And that's what this is here. In an upcoming DVD on digital sets on natural landscapes, I'll explore this technique at depth. But for now, let's use this as a way to again cast or receive a contact shadow from our temple and from our lighting. Okay, the next step that we need to do is set up an appropriate key light on the scene. If I go into wireframe here, let's take off the poly mesh and let's look at this in a perspective view. If I dolly out here, I have a directional created. Let's go ahead and shade this. What I'd like to do here is create a directional that matches the directional or the direction of the sun. So this is really nothing more than creating this about world space 0 and aligning both the directional and the sun. Okay, once I have that, I can return back to my final render view. And let's go ahead and kick off a standard render with mental ray. Let's actually not use final gather on this quite yet. Let's have ray tracing turned on for directional shadow. And let's see what we have as our first rendered view. So what we get here is a start to this. Now there's no HDR integration yet, so we have no fill light. So we have pure black regions where the HDR will contribute. Our directional light is inherently matched to the sun position based on what we just did. And we can see that we have, I'm also using my use background shader here to inherit the background image. So things are basically in place, but now we need to add the HDR fill to the scene. Okay, so let's go back to render globals. And what we'll do here is we'll slide down to image-based lighting and we'll hit the create button. And I've already done this, and let's now go to the placeholder for the HDR file that we've saved out. And in this case I've placed that in. It's spherical, it's an image file, and most importantly I can use the color gain to dictate the intensity of the HDR. So I've already found a decent setting for this. So let's now look at adding the HDR to the image and what that does. So looking between the two, I can see the addition of the skylight illumination affecting it. It pulls illumination into the shadows, which is what I want. And I've also done another step to help the lighting here. One of the problems we had with this was we had razor sharp ray trace shadows we can see against the groundscape. And by going into the light attribute itself, we can add light angle to be something other than 0. And what this does is radius basically the contact shadow to be wider and softening in distance away from the terminus of the shadow. By doing so, I need to increase my samples, my ray shadow samples, and I've put 12 in here. In fact, you'd probably want to go much higher. And it doesn't take much in terms of light angle to create what we want. And now if I go back to the difference here, I can see now I have a soft shadow emanating sharper at the terminus and softening as it moves away. So now I'm kind of more in concert with the type of shadow that I see here. Okay, so I'm lacking a few things to make this really work, and part of it is that I have kind of a bluish cast to this, which again is largely coming from the sky. But is also the fact that this was the uncolor corrected HDR. If I go back to HDR shop and color correct it with the technique that we showed and use that corrected HDR, we get this, and there's our final result from this HDR. And now the integration is starting to feel fairly tight between, so we can see the difference there is fairly major. And again, that's just taking the time to color correct the HDR. Now to finish this image, I would go into a lot more integration issues. I'd probably have some paint effects grass or some type of buildup at the corners here to kind of soften that very harsh edge. But in general, it looks like it's actually fairly well integrated. So again, this just shows the power of HDR as being a unifying factor for CG and live action. And certainly once you begin to work with it, there's no going back to the old methods. So lastly, let's show HDR integration within RenderMan using mTOR in Maya. The first thing we'll do is we'll start out looking at the Slim palette that's been created for this project. And one thing in RenderMan is that it's primarily tooled to create multi-pass renders, and you'll see that in this case. So I'm going to create a series of different passes, and some of my shaders are set up with that in mind. So this is not a one-off solution as you may be able to do in Mental Ray or the Maya renderer. So looking at our shaders very quickly, we have a stone shader which is based on a blend, and we have an image file which is the stone texture mapped to this. It's based on a projection. The projection is based on autoplanar, which is the closest to triplanar, which we're going to cover later in this disk. And then I have a surface point callout, which defines the planar projection based on an mTOR coordinate system shape. And this will get us the basic kind of rock surfacing that we have in Mental Ray. We have a basic key light here to match what's been done on the Maya side. And again, I have ray trace shadows. I have a blur and a bias added to create a soft shadow effect. I have a backplane which acts as an image plane, and in this case, if you call out the name backplane and have that checked in Render Globals, we can add that if needed. But most importantly, HDR, at least in off-the-shelf uses with RenderMan, is expressed through the IBI shader. And this is their kind of off-the-shelf way to integrate HDRs. Now, the beauty of RenderMan, of course, is that everything can be absolutely custom. And in most cases, working on large projects, you'll work with a shader writer or programmer who will be able to create probably a more deeper use of HDRs. But this is one way that you can, at least off the shelf, get started with this in RenderMan. So the IBI for image-based illumination shading model is found from File, Create Appearance, Surface, IBI. And again, this is a fairly simple way of integrating it. What the IBI shader is basically a surface shader that provides a hook for the HDR as well as just basic shading information. It's not not very robust, but it is one way to integrate it. So here we have surface color, opacity. We have a choice of either environment map or environment light. In this case, we'll choose map for the HDR. And then we have the HDR that's specified. Now, one thing about an HDR image in RenderMan is it does have to be converted to the TX file format. So to do that, let's just review under the TXMake -help, where we can see the usage of the TXMake executable. We have a few arguments that need to be placed in this to create, to convert the HDR to a TX. And in this case, it's TXMake env lattice for environment latitude longitude -float, so that we maintain the floating point data in the file. The file in, which is your HDR, and the file out, which is the TX. So this needs to be done ahead of time. It's then plugged into the environment map slot. We also have a coordinate system call out, and I'll show you one way we can change that in a moment. And then below this we have some other basic shader attributes such as reflections, diffuse, and a way to integrate shadows within the shader. So in other words, the IBI shader will disregard any lighting in your scene and offer the lighting from the HDR exclusively. With that, you could restrict potentially the shadows from your source lighting, your direct lights. This allows you a way to actually use some of the shadowing from the direct light without the light contribution. So the first thing I would do here is I've set up my my basic HDR. If I do a render, I can see it has a very soft appearance of that. What I probably should do to verify this, or to at least make sure the alignment is proper, is I usually put a source sphere in the scene. And let's go ahead and pick that as an object. Let's go to RenderMan Globals and go under Accelerate, and let's do Selected Object Only. Let's make sure our ray tracing is on, and let's see, we'll put this at a 0.5 shading rate. Actually, we can probably change this to a 1, and let's take pixel samp down to 3 and 3, and I think we're good to go. And now let's go ahead and render this, and let me call up the It window. Okay, so I can see I'm getting a basic sense of the HDR lighting. One thing, this is very averaged. I'm getting kind of the ground coloration and the sky coloration. I'm getting a very average in between. And again, for architectural surfaces, any kind of planar surface, HDR poses a bit of a thorny problem because it's going to sample, say, this resident color, when in fact it would probably be seeing more sky as opposed to this midpoint. But before we talk about that, let's go and go back to our shaders. Okay, and let's open up the IBI again. And just to verify this, let's go ahead and take reflection max up to 1, and let's take diffuse down to 0. So now I'll have a purely reflective object. And now if I go back to my It View window, we can re-render on this. And now I'll get a true indication of the position of the sun or the orientation of the HDR. And again, I've still left myself in here, and this has a pinch point. There still needs to be more work done on this HDR, but I can verify that the key light position on this HDR is in alignment with my key light in the scene, and that's critical when we do set these up. Now, if I find that my alignment is not correct, let's say if the this light source or the sun in the HDR is opposed to my key light, I could go in and do an offset in the map itself and resave out, but oftentimes it's more expedient to do it in the shader. So what I can do first of all is I can take a new coordinate system, and this is an mTOR coordinate system. We need to look at display this as a locator. And if let's look at this in perspective. And if I look at the attributes of this object, under extra attributes we have a display mode. And this display mode will create whether this is a planar, cylindrical, or spherical. If we go to display mode 1, I'll change it to a spherical. And that's in fact what I've done with this one. So let's go back to this camera view. And this is now mTOR ChordSys 1 shape. Let's now go back into our palette. Let's go to the IBI and let's plug this in. Into this field. So now when I execute my render, I can use the position of this coordinate system to basically re-rotate the bearing of the HDR. And so if I put a rotation in this, I could spin this around into proper alignment with my scene. Now later, as you begin to work with a custom shader for this, whether it's one that someone has written with you or you've authored yourself, it would be nice to advantageous to put in a convolved environment map. Right now I can get decent reflections from this, but sometimes it's best to break the diffuse out into a separate map. So if I go back to HDR Shop, we can see our original HDR file, and then this is a convolved version of that. Convolving is a special type of blur that deals with basically spherical projection. So it's actually doing a proper blur based on the projection. To execute this, we go to Image, Panorama, Diffuse, Spec, Convolution, and we would accept this. This is, as you can see, a fairly lengthy operation. Best to resample this down to a very small res. That's the other thing. This is 256 by 128. Potentially could go even smaller. So in other words, the convolve file will just offer the diffuse lighting. The reflections will be handled by the larger HDR, and that can be a very efficient way of of operating. Right now the IBI shader will tend to do both. It'll put a diffuse blur right here set on this to get that convolve. So in other words, if we take the reflection down to 1, and let's see, we have to of course bring up diffuse again because that's was brought down. And let's take this back. So again, dropping my diffuse blur will begin to reduce that effect. Just for the diffuse value, you actually want it fairly soft. But again, the convolve file will do a more optimal version of this, and again, as you get into custom shader writing, that would be a nice thing. Okay, let's move on down the line. Let's look at the occlusion shader. This is the textbook way of achieving occlusion with RenderMan, which is mapping a constant shader by a color spline, the color spline being driven by an occlusion calculation with your samples built in here. And I'll show you these different passes as we get them. There's a ground map pass, which is designed for the holdout of the ground so that I can get the alpha based on the intersection. We also put a rib box on that, which is a way to do a matte object in let's get this sized out. In RenderMan, where we give it matte 1 is a piece of rib, and that gets attached to the polygonal ground surface, ensuring that no alpha is contributed by that ground surface. The rocks have its own shader and the trees have its own shader. So now let's look at our final renders. Okay, so I think I mentioned that RenderMan is best used as a render by layer technique. And what I'm going to do here is just scroll through the different layers that were rendered from this file. This rather atrocious looking render is nothing more than the diffuse pass based on the texturing for the files. Then we have a key light pass, which is set up on a base white shader with ray trace shadows applied. And from the first two, we can then multiply the diffuse pass by the key light pass, and that'll give us kind of the beginning of the final comp. Now here's what we're interested in. This is the HDR pass coming from the IBI shader, and this is again rendered out as a separate file. RenderMan offers the use of doing a AOV file, which is its form of render by layers. So all this can come out during one render and be kind of set out into the different passes. Okay, but in this file I can see the ground illumination from below and the sky illumination from above, say in this region. What I'll do next is I'll do an ambient occlusion pass. This is what the occlusion shader did for me, and this is kind of more the time consuming of all the passes. So it has to do a hemispherical sampling with ray tracing to achieve that. But what I then do with that pass is I multiply that against the previous pass. So now we have the HDR pass multiplied by the occlusion. Okay, next down the line is we then add in the diffuse texture pass that we started with into the occluded HDR pass, and this will now give us the value of what we're going to have in the shadowed regions. Not so much the fill, we're actually going to negate that, but this is the final contribution again to the fill. So to do that, what we'll do is we'll take the key light pass, but we'll invert it. And what this will do is add a multiplier that lets me erode back where the key light would be. So this is now the true fill light contribution ready to be composited as an add to the textured key light pass, which is what this step is. So now we have the contribution of the two combined with the proper fill light contributed by the HDR. We also need to render a ground contact shadow pass, and you can see the effect of the softer ray trace shadowing, angled shadowing. And then we multiply that over the background plate. A little bit of color correction is added to try to match the two temperatures of the shadows. And then for our final, we layer over the other assembly. So now this is the final image from RenderMan. And again, there's a lot more we can do to this. We can add a lot more better integration of the model onto the landscape. Potentially do some more color correction, more shader. This is a very basic shader with no specularity maps put in. So a number of things could be done. But again, it should show you at least the steps required to do this in RenderMan and the way that HDR does integrate into the process. So the last topic we'll cover with HDR is that of animated sequences. And this is a bit of an experimental technique so far, still in its infancy, but with some great pioneering work done by Paul Debevec with his Parthenon project. So here we see the capture, which was made throughout the day, of the animated sequence. Each HDR capture was done with full dynamic range, of course, and then prepared into an animated data set ready to apply to the 3D model. And here we can see the sequence used as the background as well as the lighting source for the model in perfect unison. So I think this is probably to date the best testament to the richness of HDR lighting as a tremendous tool for architectural and environmental backgrounds. So great work by Paul Debevec and crew at ICT. So aside from temporally animating HDRs, there's also the opportunity to spatially animate HDRs as well. And this would be useful for, say, in this case, a canyon fly-through, where we'd have a lot of areas of light and shadow that, say, a CG aircraft would have to navigate through. So HDRs in this case would be very hard to establish from the real world, but if we have a 3D landscape, say from a package like Terrigen, there's the opportunity to create HDRs from that package based on that landscape. Also, there's now options in Maya with Mental Ray to establish HDRs from the scene. So again, with a bit of ingenuity, this can be arrived at. So in the end, HDR techniques are definitely an evolving science, but it's certainly a fantastic way to create realistic lighting with CG, and will continue to be so. So let's move on to the next chapter, which involves shadow techniques, and then that will complete our survey of exterior lighting technique.